All right, and welcome back. So today we are going to be starting chapter 4, and we're going to be talking about section 4.1, which is all about congruent figures. And by the end of this video, we should be able to identify the corresponding parts of congruent figures. So have out your guide and notes. Let's begin. So two objects are said to be congruent if they have the same size and shape. We've previously learned about congruent segments and congruent angles. Two triangles are congruent if and only if their vertices can be matched up so that their corresponding parts, their angles and sides, of those triangles are going to be congruent. Just as for triangles, two polygons are congruent if and only if their vertices can be matched up so their corresponding parts are congruent. And when we're describing congruent triangles and other congruent polygons, vertices are listed in order of correspondence. So for example, all the statements below are correct for each pair of congruent polygons. If we have a gander over on the left-hand side, we have two triangles. We have triangle ABC and triangle XYZ. Notice how triangle ABC is congruent to triangle XYZ. A is our first letter, X is our first letter, which means that those are corresponding parts. They're corresponding vertices, they're corresponding angles. So anywhere in a congruent statement, you're going to have A be in the same location as X. Here's what I mean. If we look below triangle ABC is congruent to triangle XYZ at the statement of triangle BCA is congruent to triangle YZX, notice how A was the third letter and X is also the third letter. In that upper right triangle congruency statement, A again is the third letter and X again is the third letter. And then if we go below that, A is the first letter, X is the first letter. So anytime we want to have a true and proper congruency statement, we have to have corresponding parts in the right order. It wouldn't count if we said, hey, triangle ABC is congruent to triangle XY or ZYX, pardon me. That would not be true because that would not be congruent triangles. They don't have corresponding parts that match up. So in order for us to have a true congruency statement, we have to be in order of correspondence. Likewise, on the right-hand side, we have another polygon. We have ABCDE is congruent to PQRST. Let's look at letter C. Letter C is the third letter in that congruency statement. Likewise, R is going to be the third letter in that congruency statement on the right, which means that anytime we see the letter C, we're going to see the letter R in the same location. Underneath that, C is the second letter, R is the second letter. In the upper right, C is the fourth letter, R is the fourth letter. And in the bottom right, C is the first letter and R is the first letter. So every time we rearrange, we're going to have the same corresponding angles and those vertices in the correct order. Please keep an eye on that. With that in mind, please work on problems 1 through 4 on the guide and notes and turn over and resume when you're ready to move on. Actually, not turn over, just look down. Sorry about that. Here we go. So the definition of congruent triangles is technically an if and only if statement. It means both of the following. If triangle LMN is congruent to triangle RST, then corresponding parts are going to be congruent. If triangle LMN is congruent to triangle RST, then you can conclude the following. Angle L is congruent to angle R, angle M is congruent to angle S, angle N is congruent to angle T, segment LM is congruent to segment RS, segment MN is congruent to segment ST, segment LN is congruent to segment RT. So that's the first. Now, secondly, if corresponding parts are congruent, then triangle LMN is going to be congruent to triangle RST. So if we have angle L is congruent to angle R, angle M is congruent to angle S, angle N is congruent to angle T, segment LM is congruent to segment RS, segment MN is congruent to segment ST, segment LN is congruent to segment RT, then you can conclude that we have a congruency of triangle LMN being congruent to triangle RST. So it's an if and only if statement. So when the definition of congruent triangles is used in a proof, the wording used is corresponding parts of congruent triangles are congruent. You can abbreviate it as corresponding parts of congruent triangles are congruent. We've also used And the kids love this. C, P, C, T, C. That also works. Corresponding parts of congruent triangles are congruent. So you can use CPCTC. That's totally fine. Awesome job. Please work on problems 5 through 24 on the guided notes. Let us know if you have any questions. Keep making yourself proud. Talk to you soon.